Hi students, welcome back. We're going to finish up chapter 16 today with integer exponents. So we're going to be looking at what happens when our exponent is a negative number or a zero. So let's do a little exploration first. We're going to look at this first example and we're going to start out by expanding it. So I'm going to write it out in expanded form and we're going to look for some patterns. So 7 to the 5th would be the same thing as 7 times 7 times 7 times 7 times 7. And in our denominator, 7 to the 9th, we would have 7 times, not times 9, 7 times 7 times 7 times 7, 9 times. So I want to make sure I get 9 sevens on here. Let's see how many. 2, 3, 4, 5, 6, 7, 8. We need one more, 9. And like we talked about in the last couple of sections, when we have the same number in our numerator as our denominator, those are going to cancel out. So I can go ahead and start canceling out my common factors. So if the 7s cancel, 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 cancel. So what I can see is since there's nothing left in my numerator, be really careful that you remember that would be the same thing as times 1. So I have a 1 left in my numerator and I have 1, 2, 3, 4, 7. So 7 to the 4th in my denominator. And so another way to write this, if we were to think about our exponent rules that we learned, we would have 7 to the 5 minus 9. Well, 5 minus 9 is negative 4. So when we see that negative exponent, all that that's doing is the negative is telling us location. And the location that it's giving us is that it is going to be in the denominator of our fraction. So this negative here means that the multiplication is in the denominator of our fraction. So that's what we want to remember. Okay, so we're going to go ahead and look at a couple other examples before we move on. And we're just going to look at using those negative exponents. So here's our rule real quick. Again, we follow the exponent rule. If we see that negative is telling us that the repeated multiplication is happening in the denominator of our fraction. So here we go. So 5 to the negative 3rd, that just means that those 5s are occurring in the denominator and a 1 would be in our numerator. So that would be the same as 1 over 5 to the 3rd. If we were to multiply that out, because when we see the word simplify, that does tell us to multiply it out. So that would be 1 over 5 times 5 times 5. Which becomes 1 over 125. Okay? Let's take a look at one more example. Now, let's do one with a negative as our base, because we know that that can be a little bit confusing and a little bit of an issue. So remember, because the negative is here in the base number, that just tells us that the repeated multiplication is of a negative number. So this becomes 1 over negative 10 to the 3rd power. So remember, that means in our denominator, negative 10 times negative 10 times negative 10. So that becomes 1 over negative 1,000 or negative 1/1000th. So we're going to start to tie together all of these rules and we're going to start to simplify a lot of problems using all of these different rules that we've learned. So we've got an expression here, and again, we just want to make sure that we're following order of operations and that we are putting all the pieces together. So order of operations, of course, first we would be inside our parentheses. And so 6 minus 4 would be 2. Don't forget to bring everything else down. Then we're going to go ahead and apply that exponent. Exponents comes next. So 2 to the negative third means 1 over 2 to the third power. And we'll multiply that out in a minute. And then 0 power. We haven't quite talked about the 0 power here. If we end up with a 0, that means that our original number, let's say it was negative 2 to the third, divided by negative 2 to the third. I put a negative in there that I did not intend to put. So what happens is when we subtract those exponents, 3 minus 3, we get 0. So basically we have the same value in the top as the bottom, and when we divide that out, we always get positive 1. Doesn't matter if the base number is positive or negative, because a negative divided by a negative will end up being a positive. So now we're just going to follow order of operations. We have 5 plus 1/8 plus 1. And at this point, we can add in any order. 5 plus 1 is 6, and 6 plus 1/8 is 6 and 1/8. So now we're just starting to tie all those rules together and make sure that we're using all of the exponent properties correctly.